So now what you see here is what I've got is two DSS servers here. If you look here on the top of the tab where I have it on using Firefox, I have Node A and then Node B. So what we're going to show is the Failover Manager that I'm in right now. So I'm running Auto Failover, and we're going to briefly go into some of the requirements of setting up your failover. And then what we'll do is we're going to install a virtual machine, and we're going to move our resources over to one of the nodes while installing it, so we can show you the resiliency of our failover that we currently have. Now I'm showing you the active-active system that I have set up right now. To go over some basic stuff that I really want to go over with a lot of people to keep a well-known and short understanding of how the failover really works is obviously you need two DSS V7s. You can also do this with V6, only just bear in mind that the V6 has the active-active, where the V7 offers the the active-passive with the DSS V6, and the DSS V7 offers both active-passive and active-active. Obviously you need a volume group, so here you see we already have a volume group already set up. If you notice that I have here in the volume manager, I have two iSCSI volumes. Now they need to be the same size also on the node B. So you cannot have, let's say, 100 gig and a 200 gig on node B and try to replicate them. It won't even allow you to do that, in fact. I'm using block IO versus the file IO. Here you see that I've already assigned replication to them. And on node B, we also have the same configuration. So we'll just go ahead and go on node B and look at the volume manager, and you're going to see that we also have the matching volumes. So here I have LV001 and 2 as well with 100 gig. Now, when you use active-active, let's go with the volume replication, and you want to be able to set for, because it's based on load balancing. So here you'll see that the volume replication mode, obviously you see one is set for destination and one is set for source. So the source one on node B, okay, from the node A side is going to be like the remote node. And obviously conversely for the node A, if we look here at the volume replication, you'll see that the source node, which will obviously represent for the volume being replicated on LV000, as being source. So you want to make sure you have that set up properly like that. And of course, for every volumes that you add on, you want to be able to balance the same way. So you would have source, destination, and so forth. Okay. And then of course your host binding, you want to make sure that you have the proper IP address that's pointing to your node B and with the password. After that, it's really simple because all you're doing is creating a task and then perform the play button for the task that you have that's on the source. Now if you notice that this source on this one, the volume replication 0, and this is for the LV00 that we talked about, is set for source, and that is currently running right now. Typically what I do after I really start the action of the replication, I usually go to status and I come right on down to task, and I look to see if the volumes are consistent. So here we will see that volume replication, the name 0 that I've created, I see that the source and destination are consistent. When it's inconsistent, usually you'll have a value and the time of when it will be completed. This is where it's happening in the beginning. So you want to be able to, before you start your replication services for your failover, you want to make sure they are represented here as consistent to consistent. Once you're completed with that, the next typical steps you want to take is going into the iSCSI Target Manager and make sure your iSCSI IDs, your LUN numbers are the same, and your target names are the same. Let's take a look at it. If I go to Configuration, iSCSI Target Manager, and then Targets, here you'll see I've created two targets, Target 0 and Target 1. Now Target 0 is going to be my Node A local resource. And here you'll see from my target volume that I have this LV00, and then also the SCSI ID and LUN number are going to be the same as node B. Let's verify. If they're not the same and you try to start the failover service will alert you to let you know that you're not configured properly. So this saves time on researching, and also the importance is to match everything, so when you do failover services, that your initiators have the same information. So this is why it's very important. It doesn't matter if I have LV000, so I can have different volume names. Okay, that's okay to have, and I did that for this purpose, so that way everybody understands. So if we look at the node A, I'll have LV00. But if you look here at the last letters, let's say LKO, here's the SCSI ID right here. That must match. The LUN number must match. Now let's take a look on node A. We said LKO and LUN 0, so that matches. Now the target name. The target name is right up here, or you could scroll down on the bottom and you'll see the target name here. You do not want to change this format here where you see the IQN dot, of course, the name, the date convention, and the colon. You want to make sure that those parameters are set, and also another dot for the target name. So you can change that, but don't change the structure word, the dot, the colons, and the dot as for the name on that target. So you want to make sure that is the same naming convention, and let's take a look on node B. If we scroll on down, we see that it says node A, target 0. Now if you notice on target 1 here, on node B, what I've done was I've named it for node B, target 1. This indicates that for documentation records, I've seen a lot of cases where people don't write down the information of where their data is residing on, which target, which server, is it node A, node B, and the reason why I name it like this is to help structure the naming convention, and it helps also the engineers keep aligned with where their data is stored to what target. So here we got node B dot target 1, and of course if we go to node A, it should represent the same. And again, we also want to verify the SCSI IDs are the same. It doesn't matter whether if node A has a SCSI ID, it just, and or node B, just make sure that both have the same SCSI and LUN number the same. And here, if we look down the bottom, we see that I have node-B.target1. So I know that this is really nodes B's resources. Once you're done with this, it's really simple to go right into the setup failover and begin your failover configuration. Here, what you want to have is at least minimally of 2 auxiliary ports. What you want to be able to specify the volume replication port, which I'm using this .6220 to replicate my volumes at the volume replication level, and I give that a dedicated NIC. And then of course, one of my virtual IP addresses that I'm going to be used for those storage access NICs. So here I'm using the 2.220 and 2.221. And I like to keep my IP addresses and my pretty much same in the same family. So it kind of works together. Here I have ping nodes. Again, you want to have as many ping nodes as possible. Typically 2 or 3 are fine. In some cases, you might want to add more. What is a good ping node? Well, a firewall, a VMware server, possibly a UPS that has a lot of uptime. Anything that has a lot of uptime you really want to look into. Okay, so now let's go all the way down. The failover trigger policies are important. I like the defaults. This way, if I have multiple volumes that I've created, I want to make sure that if they're on the same RAID array, in the RAID controller, that there could be something wrong with the controller, and I don't want to risk it. So here, if I have, let's say, 2 RAID sets, let's say a RAID 10 and a RAID 5, and my RAID 10 is where all my iSCSI targets are, but we may have a problem with the RAID controller on the RAID 5. You want to make sure that any events or I/O errors on any volumes, you want to be able to trigger a failover if that event, because you don't know if it could happen to the controller, but it's happening to the first array. So keep that in mind. That's why we have that there. Here we are into the main area, the resource pools. What we have here is really, you start off usually with the virtual IP addresses. And the virtual IP addresses is where my iSCSI initiators will be connecting to. In this case, we're going to be using VMware, and we're going to be connecting to the IP addresses here. Of course, you see that I have more than one, and that's because I might want to use MPIO. So MPIO, you're going to need 2 virtual IP addresses, which means I'm going to need 2 extra NICs for this node to be able to utilize MPIO. And of course, I'm going to need 2 extra NICs on node B. So it really comes out to a total of 4 NICs. You can do bonding as well. We do have a best practices for zero downtime where you're bonding pretty much all your NICs, including for the volume replication. So here you set your virtual IP addresses. My virtual IP addresses are outside the subnets that I have here, the network addresses of 3.220, 5.220, 2 and 1.220. You'll see that the virtual IP addresses are in different networks. So I got 10.1, 11.1, 12.1, and 13.1. Now next are my iSCSI resources. So here, if we click here, we want to make sure that this is my local node. It's noted right here. And if we look, here is where I talked about the naming convention for the targets. So here I put node-A, which tells me that this is the local node's resources. So in case I move the resources over to the remote node, and I were to restart this system, connectivity is still going to be working, your data is still going to be flowing from your initiator, and all the resources will be on the remote node, so data is continuing, and we're going to demonstrate that. So here on the bottom for my remote node, you could see that when I go into my iSCSI resources, that I know that this target, node B, target 1, is the source for node B, and so that's my remote node. Okay, so I just want to make sure everybody understands that. It's real simple. And once you categorize that in your naming conventions and your planning, it's easier to understand what's going on without too much documentation for your administrative notes. So, and again, you can notice here that the remote volume for that is the source, and then of course the logical volume that is on the local one is called the destination. Now, let's go take a look up at the top. If we scroll all the way up, you'll see some information that we have the resource pools. This also gives you some information about the local node and remote node. Here we have some information at the ping nodes. If you click on, let's say, details of the ping nodes, it just takes you right on down to this highlighted area that you've wanted to find more details on. So if we see that all this information is correct, if you try to start the auto failover and you will receive an error, one of these areas will kind of point to an area that you need to correct. Once you do this, it's pretty much ready to go. Now, just to give you an example, when we kind of move our resources before we actually demonstrate with the VMware ESX server, if we scroll down, let's say I wanted to service node A, and I wanted to restart the system, make some adjustments, or add some more memory. What I would do is make sure I'm on the iSCSI resource area, and here go to move to remote node. So as I move, what it's doing is it's moving that volume over to the remote node, and what's going to happen in the volume replication, it's going to put that in a destination mode. So if we just give it a second as we're moving, now it's done. It's located on the remote node. Here, if we go to Configuration Volume Manager and then Volume Replication, let's scroll up and take a look. Now you notice before we had set that to source. Well, now it's switched over to destination, meaning that all the writes will go directly to the remote node. So we can reboot this system. If there were a lot of heavy loads coming on one of the servers and you have a more powerful server, then you can shift those resources over, such as what we did a second ago to move the resources over to the remote node. Now let's go put it back. So we just go to Setup, Failover. And here what we're going to do is move back to local node. So what's really flexible and really nice to have this flexibility is that it allows you, without any data interruption or loss or disconnects from the initiator, to allow these resources to be moved freely for you to service, to maintenance, and for other administrative reasons. Okay, so now let's go ahead and go into the VMware I've set up here. So I'm using my vSphere client to connect to my ESX server. Just to let you know, basically, if you want to start off something very simple to understand how I'm connecting to that target, I just go into the storage adapters and I click on my iSCSI software adapter. And here I have my volumes, my iSCSI targets that I've created from those iSCSI volumes. So now, I basically, to be able to get that, is to let everybody know I just went and I used static discovery and I entered the IP addresses and also the IQN name. I don't use dynamic discovery that much. Some do, but especially when you're in an HA environment, keep in mind that it's always good to use the static discovery. Once you enter those IP addresses in the initiator here, then you'll be able to mount these volumes that we are seeing now. And of course, you'll see that the LUN type is 0 and other information, and you can look at the paths. Right now I'm using MPIO, so I'm active. Once you're done with that, then we just basically need to go right up here to the storage and add the storage. So I have one set right now. Let's go ahead and add a storage for the other one. Here we want to select disk/LUN, so this will create our data store. We see that there's the one that we've created, and this is probably going to be for the node B. We'll take the default on the VMS-5. Select OK, and we'll name it node B. We'll take the maximum amount of space and we'll complete it. So it's in progress right now. You're going to see that the data stores that I have are available for node A, and then momentarily you're going to see node B come right up behind it. Now what we're going to do is go ahead and we're going to install a new virtual machine. So here's our node B and our node A. Currently there is nothing in the data store, so we know that they are empty. And now let's go ahead and create a virtual machine. So we'll go select here onto the IP address of the ESX server, click on the new virtual machine, and I like to go custom sometimes. You can take the typical. So here we'll just install DSS v7, and here we'll select our data source. So let's use node A. We'll select the default on the virtual machine version 8. And DSS is a Linux-based OS. We're actually Debian, so I'm just going to take this to 64-bit. And I think for number of sockets, that's good for this demonstration purposes, because all we're doing is just a base installation. I usually like 2 gig of memory for DSS. On a virtual machine, you probably want to add more if you're using NAS functions, if you're doing more replications, and probably 4 gig would be more than enough for a low amount of data. Of course, specifications on even higher capacities. If you're doing a lot with a DSS, you're using snapshot, all those you have to factor in. You may need to add more than just 4 gig. So here I'm just going to demonstrate with 1 NIC. Of course, you can add many NICs. And we'll take the default SCSI controller. And we're going to create a new virtual disk right here. I only need 2 gig for DSS to be installed on, so I don't need any more than that. And we'll take the default on the virtual disk, so we'll just leave that at the SCSI 0.0. Now I'm going to be wanting to edit it before I go ahead and start the virtual machine, so that's an easy step, and it takes you right there to the window where I can edit my virtual machine properties. So what I want to be able to do is I have an ISO image that I'm going to load up and mount that I've created a data store by using NFS. And I'll show you that in a second. So here I've created what's called a share that I've developed on the NAS server. And if we look here, there is my DSS v7 ISO file. And I want to connect power on. To let you know where that file is located on, if we go into one of my DSS servers, and what I did was I created a share under configuration, NAS resources, and shares, but I'm using NFS. So you want to make sure that if in configuration and NAS settings, just click on there, scroll on down, and make sure that you select to enable the NFS protocol. From there, then what you want to do is go to configuration, NAS resources, and then shares. And here, once you create your new share, here I've got ISOs. you want to make sure that the NFS protocol, not only that service is enabled, but you want to enable it for that share, because we don't by default enable all file protocols for every share you create, or you would sometimes wouldn't want that. So here I'll make sure that I just took the defaults for NFS. I could do allow and write access, where I could set multiple IP addresses separated with semicolon here. Here you have other options doing insecure, synchronous, insecure locks, all squash, no root squash, and some more advanced options. By the way, if you need more information on that, you can always click on a question mark on any DSS V6 or V7 function, and you'll get detailed information about each of those features inside of that function. Okay, so this is what I did when I created the to be able to mount that for the DSS to the VMware server. Let's go ahead and finish this so I can show you. What I did was I added storage, and I selected the network file system. And here is where I set the IP address of the DSS server, so it was like 192.168.1.221. And of course, when you do the folder, do it as a / and of course the name. And of course, give it some naming convention, testing 1, 2, 3. Now I've already got one in there, so we're really just duplicating the efforts, and we'll say it'll already tell you that it already exists. So, but this tells you that how easy it is to put your ISO image files up there so you can do your installations. Here you can browse the data store. So I see I also put a Windows ISO up there, also the DSS V7 version. So you can have multiple operating systems loaded up here for you to create your virtual machines. All right, now let's go ahead and start our virtual machine that we've created on DSS V7. I want to click on it, make sure I have my console screen settings ready to go. Right click on it, then go to power on. Now in this demonstration, what we're going to do is we're going to make sure that we're going to select the software installer, although you can boot it up just to test and verify other performance values, or if you want to run some other tests to make sure that before you do the installation, that DSS is functioning fully. So while that's loading, let's get ready, because what we're going to see is go ahead and I want to get a percent value shown up here. But what we're going to do is, going back to this, we're going to go into the node A, and we're going to make sure, let's go ahead and update and refresh, because what we want to do is we want to push it back, make sure everything's back to its original position. So here we have the local node is properly set, and we know that's the remote node. And on the node B, we want to make sure everything's set properly on that before demonstrating this test. So you always want to test your failover in this configuration. You want to move your resources over while you're doing installations to verify that your replications are working fine, your failover functions are set properly. So here, everything looks good. So we know that node A is the remote node, and this is again helpful for your naming convention to help you guide you through. Let's go back to, here we are at the DSS, we're installing. So let's go ahead and select agree. We're going to select that 2 gig that we created for the virtual machine. We're going to now tell the DSS to move the remote node resources. So we're moving right now, and at the same time, we're still copying files, and we're still installing. Let's see if the resources moved over. Okay, we're still moving. It's over to the remote node. Files are still being consistently checked. We're at 100% complete, and we're ready to reboot. Now, let's go ahead and reboot it. Actually, we want to shut down. The reason why is because we want to make sure that we edit the virtual machine properties to make sure that it doesn't not load the CD-ROM again. So while it's shutting down, let's go ahead to the edit settings for that virtual machine. I'm going to select the CD/CD drive. I'm going to take the power on and connect off. We'll go ahead and power on the DSS V7. Go back to DSS V7 over here on node A, we're going to move back to the local node. So we're going to bring over from the remote node, move our resources back to node A while we're booting. So you can see we're loading. We can also do this right now after what's complete. We can also move the remote node resources to the local node. So here we're done. You can see how fast it is. It does a really good job on it. Verifies the data integrity. It does error corrections if there's anything happening in the background. But now all the resources are back. Now we can move the remote node resources over to the local. So here we're still loading up DSS. And let's go back to, you can see the counters are going up. So there's no performance delay. So that's a beautiful thing to have with the DSS active failover. So here I have now both my resources, my local is to local, and my remote is moved over to local. So now I can just move it back if I want to. So this is showing how you could just work with the resources to your advantage for maintenance, administrative things, or just preventative maintenance, scheduled maintenance downtime as well. So here you're seeing the updated message that it's now moved over to the remote, and DSS is installing and updating and booting. Well, that's it, everybody. Thank you very much for attending the webinar. Hope this helps with the overview of the iSCSI failover and testing your virtual machines and installing your virtual machines. Take care and goodbye.